All right, let's check our answers from yesterday. These are just being simplified. So we're not solving, we're not getting like n equals something or b equals something. We're just simplifying, we're combining like terms. So number one, we go through and, like I said, I go left to right. You don't have to. You can start with a variable, but it's just easier for me to keep track of. So -6 minus 4. Those are the two numbers that you can combine, which becomes -10. Okay, -6 minus 4 is -10. And then -8n plus 9n is 1n, and it's positive. So -8 plus 9 is positive 1. So we don't put 1 in, we just put n. Now if you put 1 in, you're not wrong, but we want to get out of that habit, okay? So we have -10 plus n. This one, we can only combine these two. We can combine them. So 3b minus 7b is -4b. Okay. This one we need to distribute first. So I'll do a first row here. So -2b. And then you take -9 times 4, which is -36. -9 times -5b, which is plus 45b. Because remember, negative times a negative is positive. So 9 times 5 is 45. And then you got b there. Then you look and see, can I combine any of these? I can combine I should have crossed these out, sorry. I can combine the -2b plus 45b, which becomes -2 plus 45 becomes 43b. And then you still got your -36. Okay? And that's a b and that's a 6. Because they look a lot alike with my handwriting. 6p plus 4p is 10p. So 6 potatoes plus 4 potatoes, you have 10 potatoes. Okay? Then 2 minus 4 is -2. And then, so you got rid of the numbers, and then you have -3z. That doesn't combine with anything else, so you're done with that. Here's another distribution. 4 times -7 is -28. 4 times -6k is -24k. Now, as opposed to this one, there's nothing to combine here. So you're done. This one, 3y minus 8y, is -5y. Okay. And then 4 minus 5 is -1. Okay. So there's your answer there. This one you can do 3f minus 6f, which is -3f. 3 minus 6 is -3. And then you're just left with that -8. Okay. And then the last one here, I put some exponents. So let's start with the x squared. We can do 10x squared plus 2x squared is 12x squared. We can do 4y minus y, which is 3y. And was there another y? No. 4y minus a y is 3y. Then there is no other x, so that stays the same. 4 plus 8 is 12. And then -2y squared. There is no other y squared. So that's all the things. I can't combine any of these. So that is my answer there. That's simplified as best as we can. Okay, so check those. Go back over if you missed one or like little things like forgot to not put a 1 in or something like that. It's okay, you'll get it more with practice. If you missed a lot, go back through, watch what you can combine, see where you did. If you have questions, email me. That's the best way to kind of correspond with me, so we can go through that. But those were those answers, okay? So now let's take this. Now we're gonna, for a little bit, we're gonna build another foundation here. And then eventually it'll come back to where we're doing what we do today with this as well, so that kind of all come together. But we do need to know, we always need to keep in mind now, what can we combine, what can we put together, what can we not put together. We're going to get into two-step equations now. Okay, now don't panic because there's nothing different as far as we're still solving like we did one-step equations. We're still having it solve, x equals this or y equals this, and we still do a lot of the same things, except that instead of doing it and being able to solve it in one step, like where we had x plus 7 equals 15, and all we had to do was one step, and we solved. Now it's going to be two steps. There's going to be a little bit more to it, and we have to go two steps. And the hardest part of this is going to be deciding, making decisions, okay? And so I really want to stress that there's more than one way to do these. You want to do what's most comfortable. I'm gonna be modeling what I feel like is the easiest and most consistent. But you can differ a little bit. And I don't want us to necessarily panic and say, well, I've made the wrong choice to begin with. You can come out to the same answer in different routes. It's like those books I remember buying as a kid. You could pick one way and read, and then I was always going back and making different decisions and just read the whole book anyway. But basically, there could be different routes, but there's going to be the one that's going to me, be the most easiest and consistent. And then, and part of that's going to be because we want to keep it as simple as possible. One thing that we want to avoid as much as possible is fractions, because once fractions get involved, you can make it harder on yourself when you don't need to. Okay, and I think most people agree when I say that they want to avoid fractions. So let's take a look at a problem here. Okay, and these were the ones I was talking about that I try not to make up on the spot because we want them to come out even and not have to deal with fractions. So here's an example of a problem. Now that looks hard, it looks crazy, but I promise you that at the essence, it's still what we did, earlier. An example of this, now don't copy this because this is going to be the problem we work, but we've been doing problems like this, okay? We did one step. Remember, instead of dividing by 4, we multiplied by 4, and so we solved it in one step, okay? So that, don't necessarily think, oh man, that just looks like a lot. We're solving, we've solved things like this. We've solved things like a plus 2 is 6. We're just now, it's a little bit bigger where you're doing two things at once. Now, in a problem like this, we have to decide, okay, our main goal is still to isolate the variable. That doesn't change. And, we're still trying to get the variable by itself, and we're still trying to solve. Now, I did notice on some of you guys' works when I was going through, and just to give you a heads up on those assignments, I can't, because I have almost, 75 to 100 students total, unfortunately, time-wise, I can't go through and individually, fix every problem for every student. What I do, though, is I do post the answers like we just did so that you can go through and see what you made mistakes. So when you're turning those in, I'm grading those as far as completion, and I am looking through to make sure you're doing the problems and trying them, and if you make a mistake here and there, that you're catching those as far as hopefully when I'm giving you the answers. So one thing I noticed of a common mistake that I saw more than once was the first part when I was having you put the variables on the left side, and I was doing that to avoid confusion, but we've got a little bit that we need to clean up there. I'm noticing some are switching places when they're putting it over here and putting it over here. A good example was something like 8 equals 2 minus a or something. I was noticing when you flip places, you made it a minus 2 equals 8. Well, that's a totally different problem. That is not putting exactly what's over here. You're switching places. You say, well, why is it a big deal? Well, let's say a is 4, or let's make it a bigger number. A is 6. when you put it, well, I'm trying to get one, well, it's gonna always be that way. So let's say A is 6. In this case, you got 2 minus 6, which is negative 4. But if you put it over here, 6 minus 2 is 4. In this case, it really needs to be negative, the answer would be negative 6. But you get totally different things when you're switching places like that. Let me take this out of it so you see more what I mean. When you're putting this over here, if this was 6, 2 minus 6 is negative 4, but if you put 6 here, 6 minus 2 is positive 4. You can't just flip places. Okay, so what I mean by just flipping it to put the variable on the left, you need to put this exactly over here in this order. Okay, just like that. Then on this side, you put just like this. Okay, that'll make a difference. So I noticed a few were doing that, and I think hopefully you saw when I did the right answers that you saw what you did, but just in case there was still some confusion there, make sure when you put this over here, don't change the order at all. Put it exactly the way it is, okay? So we did that, okay, so we got that. So now we can solve it with the variable on the left side. Okay, so the second step, now we've got to make a decision, okay? And this is where I'm going to try to make it as simple as possible. So when you are moving the 2 and the 4, one of them you're going to have to subtract, one of them you're going to have to multiply. And it's like, well, which one should I do first? Because to get rid of the 4, you need to multiply. To get rid of the 2, you need to subtract. And you're having to decide, well, when you have, you got to remember when you're multiplying or dividing, you got to do the whole thing. So to avoid big numbers here, the best thing to do is to get rid of this 2 first, okay? Because you can move the 2 by subtracting it, and it goes away really quickly, okay? So let's do that. Let's say, okay, I need to move the 4 and the 2, but let's move the 2 first by subtracting it. Remember, we want this gone, so we want it to be 0, so we subtract 2. So over here, I'm going to subtract 2 on this side of the fence. So now all I'm left with is this a over 4 equals 4. And like I said, the reason to do that is when you start multiplying right away, your numbers are big. This would have been an 8. This would have already been a 24. The numbers get bigger, and if this number's big, then it gets really, really big. So the best thing to do in this case is to get rid of the 2 first, okay? Now, if we look, now we have a one-step problem. We got it to where we've been doing. And so instead of dividing by 4, we do the opposite, which is multiply by 4, and we get a is 16. Okay? Now I can always plug this back up into the original equation. 16 divided by 4 is 4. 4 plus 2 is 6. Okay? And 6 equals 6. So that's a correct answer. So, that's an example. It took us 2 steps. We had to do this step and then this step. But there is an easy way and a hard way. Now, just to show you real quick, to not make you afraid of, well, which one do I choose first? We could have done this problem the other way, and it still would have come out to the same answer. So I could have started out by multiplying by 4. Oops. But you got to multiply the whole thing by 4. So you would have got a, and you got to distribute this, plus 8 equals 24. And then you would have subtracted 8, and you would have got 16 still. Okay, so there's more than one route there, but sometimes there's an easier route. Now, one that is definitely easier, let me grab one of these examples. Okay, let's look at this one. Oh, I don't know why. It's number 6 on this paper, but we'll make it number 2 since you've not done 2 through 5 here. So negative 1 equals 5 plus x over 6. So let's go ahead and just real quick switch places. Okay, so I put that exactly here, I put that exactly here. Okay, that just, not a hard step, just makes it to where the variable's on the left side. So here we've got this problem. Now, one thing that hopefully you see the difference between this kind of problem and this kind of problem, okay? We're gonna have to get rid of the 5 and the 6, okay? And just like over there, we had to get rid of the 4 and the 2. But if you notice, this 2 was not part of the fraction, okay? That's why we were able to just subtract it real quick and get rid of it, and it was gone. I can't do that over here with this 5 because this 5 is part of the fraction. So I can't just subtract 5. I would actually have to subtract 5 over 6, or I'd have to, make this part of fraction. You have to deal with fractions. So this problem is different than this one. Okay, I want you to see that. And I want you to, if you have to run it back a few times, really look at why that is. This 5 is part of the fraction. This 2 was not part of the fraction. So that was the main difference. That's why we could move just the 2. It was out by itself. I could just subtract it and it was gone. In this case, okay, unless we want to deal with 5, 6, or 6 over 5 and work with mixed numbers and work with fractions, the best thing to do with this problem is to go ahead and get rid of this 6. Okay, because then all we have to do is, yes, we're multiplying the whole thing by 6, but see, because this is part of the fraction, this is just what's left. I'll make sure to multiply this side by 6 though. So in that case, we got rid of the 6. Now we're left with a pretty simple problem, okay? Because of this going away, we were just left with this, okay? Now, at that point, all we need to do is move the 5 now, and it's out by itself. It's not a fraction anymore. We don't have to worry about fraction rules. We can just subtract it. It's gone. 5 minus 5 is 0. This is a positive x. We don't need the plus sign anymore. Negative 6 minus 5 is negative 11. That was another mistake I saw from time to time. Make sure if you're subtracting and they're both negative, remember it's negative 11. Because I saw some of this, and that's an integers thing. That goes back to when we were learning, adding and subtracting negative numbers. I was noticing a lot of times people were putting 11 and not putting the negative. So make sure you follow your integers rules, okay? So let's keep going with a couple more of these. They're not all gonna, actually these are probably 2 of the more difficult ones because you do have fractions in them, but it shows that you do 1 step, do 2 steps, and you're done. And I promise you, the hard thing about these are not gonna be the math. It's gonna be, just getting used to moving those things. Always, always go back to your goal of you're trying to isolate the variable. You're trying to get that variable by itself, okay? Let's look at, this one's actually a little bit simpler, okay? This is actually number 3. For one, it looks nicer because there's no fraction, okay? There's no fraction. Also, what's nice is the variable's already on the left side, okay? So, but there is gonna be a wrinkle on this one. Math always does that, it seems like. But let's see what happens, okay? So in this case, I need to get rid of this 7 and this 9. I gotta isolate this x, okay? So I can either, if you're trying to get rid of the 9, instead of multiplying by 9, you divide. But remember, you'd have to divide this whole thing by 9, and you're gonna have a fraction here. So we don't wanna do that yet, okay? But if we can move this 7 that's out here by itself, okay, it's easy to get rid of. All we have to do is add 7, okay, and that's going to go away. But make sure you add 7 over here on this side of the fence. Okay, it goes away. You're left with 9x. Now here's the wrinkle. We wanted this to go away, 0, we don't need it. We can't leave this blank though. Okay, we can't have everything disappear and just have 9x. We've not solved for x. We need to show that there's nothing over here. Well, we need to go ahead and put the 0 over here. That way we've got 2 sides still of the equation, okay? So that's the little bit of wrinkle. Yes, it disappears 0, but we don't need that. That 0 can disappear over here. Over here we need to see it, okay? Then I still need to get rid of the 9, so I'm going to divide by 9. Instead of multiplying, we divide. And 0 divided by anything is 0. So my answer ended up being 0, okay? And if we plug that back into the original equation, I always try to remind you, you can do that. If you're unsure of an answer, put it back in. 9 times 0 is 0. 0 minus 7 is negative 7. So that becomes a true statement because negative 7 equals negative 7, okay? All right, let's look at another. Let me see if I can find one that has no wrinkles. Okay, let's make this number 4. Okay, so same concept. We don't want to divide by 9 yet because we have, it's going to look like that. You've got a fraction. You can just get rid of this 1 very easily by subtracting it. Okay, but make sure to do it over here as well. They cancel out. This is going to be negative 81. Okay, then I can divide by 9. And x is going to be negative 9. Negative divided by positive is negative, okay? So that one was a little bit less wrinkly. I just had a mental picture of an old math problem. Okay, so let's look at this one. This one's going to put a distribution part to it, okay? So this one could almost qualify as a multi-step because we're gonna have to do a step and then it's gonna be a 2-step equation. But they're kind of funny with that, just like the ones that we had to use the negative x and solve for that. But let's first distribute, okay? So 2 times n is 2n, 2 times 5 is 10, and then over here we still have negative 2. You're not distributing this, only distribute what's in the parentheses. Over here, there's nothing to multiply by, therefore it's still just negative 2. You need it, can't get rid of it, it's there. Another thing, if you notice, I couldn't add n and 5. Okay, they're not like terms. That's why I had to distribute. Now we are looking at a problem like this. We've got 2 steps. The first thing we can do is move the 10 by subtracting it. Okay, that's going to be 0. Over here, we have negative 12. Okay. And then the last step is, hopefully you've maybe thought of it, instead of multiplying by 2, divide by 2, and you have negative 6. Okay? So those are some of the problems you're going to start seeing now in 2-step equation. Now I'm going to only put a few up here for your assignment because these take a little bit, take a little while. Okay, so work through these. Now I will tell you, I don't think, you shouldn't end up with any fractions as an answer. Okay, I think that's been the case pretty much so far. Make sure you're checking, if you end up with a weird fraction or something as an answer, you've done some step wrong, so kind of go back through. But let me put some of these up here. Okay. Okay, r over 20 minus 5. We did that one. Let's do this one. This marker is going out. Those that have had my class before know that I make a game of throwing these into the wastebasket, but virtual learning, you can't do that. Let's see. We did that one. Did that one. I'll put this one, well, no. Okay. And put a couple more here. I will give you a couple directions here, just to remind you, this is part of the fraction, so you can't move it first. Okay, you're gonna have to move that first. And then this one, see, these are opposite, and this one's like this one. This is not part of the fraction, so you can move it first before you move the two. Okay, so those couple examples. Over here, make sure you distribute first. Okay, multiply times that and that. Okay, make sure you do that first and then start your problem from there. Okay, so go through those and then we'll keep working at it. Getting near the end. We're getting near the end.